Okay. So what we've got today is solving linear equations involving addition or subtraction only. Now, this type of questions have been broken down in such a way that when you see them, you might think to yourself, I know the answer by common sense. Why am I learning this? The reason why is it's okay to know the answer by common sense, but the process is necessary for you to know when these problems are fixed into more complicated questions and you have to apply them with other topics as well to solve a single question. So once you can master the process in isolation, then you can be able to do it when it's fixed into more complicated questions. Okay, so we're going to go into questions now, and it will make more sense now and down the line. Okay, so now we have a question. X plus 2 is equal to 7. The question usually says solve or find x. Okay, now the first thing we've got to consider is to solve or to find x, we want to get x on its own. Okay, second thing to consider, how do I get x on its own? That means I have to get rid of 2. Okay, third thing to consider is what connects x to 2? That's a positive sign. Fourth thing, so I use the opposite sign to get rid of 2, okay, which is a negative sign. And finally, whatever I do to the left of the equals to sign, I have to do to the right of the equals to sign. Okay? Now this is the thought process I was talking about. Okay? So, the goal is to get x on its own. I can do that by getting rid of 2 from the left. So identify the sign connecting 2 to x. That's this plus sign here. And so I use the opposite sign by subtracting 2 from the left. And then finally, whatever I do to the left of the equality sign, I have to do to the right. So if I solve this question to the side here, x plus 2 is equal to 7. So plus is the sign connecting 2 to x. So I use the opposite sign. I subtract 2 from the left. But now, because whatever I do to the left, I have to do to the right, I subtract 2 from the right as well. And so on the left, that's x plus 2 minus 2, that's 0. On the right, that's 7 minus 2, which is 5. Therefore, x is equal to 5. Okay, now make sure you copy down that thought process and try to follow it, and it should keep you out of trouble and be able to understand how to approach every question with solving linear equations. Now, I have y plus 3 equals 1. Solve or find y. So, to find y, it means put y on its own. To put y on its own, I have to get rid of 3 from the left. To get rid of 3 from the left, I need to identify what sign connects 3 to y. It's a plus sign, so I use a negative sign. So I have to subtract 3 from the left. And if I do that from the left, whatever I do to the left of the equals to sign, I have to do to the right. So that's y plus 0 equals 1 minus 3, that's minus 2, y plus 0, that's just y, equal to minus 2. Okay? Now, I have m plus 7 equals minus 2. I have to solve or find m. To find m, or to solve, that means I need to get m on its own. So I need to find a way to get rid of plus 7. I identify the sign connecting 7 to m, that's a plus sign, and I have to use the opposite sign to get rid of 7. So I use the minus sign to take away 7 from the left. But remember, whatever I do to the left, I've got to do to the right. So I use the minus sign to get rid of 7 from the left. Or whatever I do to the left, I've got to do to the right as well. So I subtract 7 from the right as well. Okay? Now, on the left, 7 minus 7, that's 0. And on the right, minus 2 minus 7, that's minus 9. So m plus 0, that's m, and m is equal to minus 9. Okay? Now, if you don't understand this subtraction that has been done in an earlier part of the series of learning, you should have watched those videos before you get to this point to make sure you understand everything step by step, building blocks as it were. Now, I have n plus 3 is equal to minus 8. Solve or find n. Once again, to find n, I want to get it on its own. So, I need to get rid of 3 away from n. Now, the sign that connects n to 3 is a plus sign, so I have to use the opposite sign to get rid of it. So that's a minus sign. So I say n plus 3 minus 3. Okay? Now finally, whatever I do to the left of the equality sign, I have to do to the right. So that's minus 8 minus 3. So on the left, I have n plus 3 minus 3, that's 0. And on the right, minus 8 minus 3, that's minus 11. Okay? So n plus 0, that's n, equals minus 11. Now, so far, we've dealt with questions that involve using subtraction as the opposite sign to make the letter stay on its own. Now we're going to flip that around and see how it works. Okay? We'll go into a few questions shortly. Now I have a question. X minus 2 is equal to 7. Okay? Solve or find x. To find x, I need to get x on its own and everything else away from it. Okay? So, 2 is right next to x, so I need to get rid of 2 from around x. Get it away from the left. Okay? So, I identify the sign connecting 2 to x. It's a negative sign, minus sign. So I use the opposite sign, you can call it a plus sign or an addition sign, to get rid of 2 from the left by adding 2 to the left. And what I finally have to consider is whatever I do to the left of the equality sign, I have to do to the right. We start by saying x minus 2 is equal to 7. That's the question. When I go through my thought process, I know to get rid of 2 from the left to find x, I have to add 2 to the left. And if I do that to the left, I've got to do that to the right as well. Add 2. So on the left, x minus 2 plus 2 minus 0, that's equal to 7 plus 2, 9. X minus 0 is just x, so x is equal to 9. Okay? Now, of course, in your head, you can figure out that by common sense. But the reason why we show this process is not for simple questions like this. is when you start dealing with more complex situations and you need to apply this process to make sense of a more complicated problem. Now, I have another question. Y minus 3 is equal to 1. Solve or find y. To solve or find y, I want to get y on its own. So, I have to get rid of 3 from around y. To do that, I identify the sign that connects y and 3. That's a minus sign. So I use the opposite sign to get rid of 3. That's a plus sign. So I say y minus 3 plus 3 to the left. And finally, whatever I do to the left, I have to do to the right. So I add 3 to the right as well. So y minus 3 plus 3 minus 0, that's equal to 1 plus 3, that's 4. So y is equal to 4. Once again, I have another question. M minus 5 is equal to minus 13. Solve or find m. To do that, I need to get m on its own. So I need to get rid of anything connected to m. That's 5. I identify the sign that connects m and 5. That's a minus sign. And I use the opposite sign to get rid of it. That's a plus sign. So I say m minus 5 plus that exact number I want to get rid of, 5, is equal to minus 13. Because remember, whatever I do to the left, I've got to do to the right. So I add 5 to the right as well. And on the left, minus 5 plus 5, that's 0. And minus 13 plus 5, that's minus 8. So m minus 0, that's m. And that's equal to minus 8. Okay? Once again, if you're wondering how I did minus 13 plus 5, that's in a previous video of the series, and you should have watched that before you get to this point. Okay? So, it's like a domino effect. Follow the previous videos, understand that before you move on to the next one. Okay? Finally, I have n minus 6 is equal to minus 14. Solve or find n. Okay, so I want to get n on its own. So I have to get rid of anything connected to n. So that's a 6. So I identify the sign that connects 6 to n. That's a minus sign. So I use the opposite sign to get rid of 6, which is a plus sign. So I say n minus 6 plus 6. But now I've got to remember that whatever I do to the left of the equality sign, I've got to do to the right of the equality sign. So I add 6. Okay? And so when I do that, I have n minus 6 plus 6, end up with minus 0 is equal to minus 14 plus 6. That results in minus 8. And n minus 0, that's n. And on the right, it's still just minus 8. So n is equal to minus 8. Okay? Please take your time to follow the process, understand it, watch the video as many times as you want, and practice questions along with it. And before long, it'll stick. Okay? Thank you very much. You've been listening to the Math Done, and until next time.